So just a little bit of background to those of you who are new to GIRI and haven't been with us before. A few years ago now, we did some research into what the industry wastes in correcting error. And we showed that we were wasting about 21% of our turnover in the UK, which is about 22, 23 billion pounds a year. Unfortunately for the world, really, our survey didn't show anything that was particularly unusual. I saw a publication in the last couple of months from the United States where they reckon that they are wasting 17% of their turnover in correcting error. So not exactly the same, but not a million miles away. So I'm afraid we all seem to be not as good at it as we would like to be. So the next slide, please. So we've set out here just some of what were the key root causes of error that we found when we were doing that research. And as you would see, the things that really affect the root causes of error are planning, culture, design, and communication. And interestingly, while workmanship is clearly a factor of poor workmanship, a factor of error, it wasn't seen as a root cause. So to try to address this issue, we set up GIRI as a not-for-profit subscription-funded company. Next slide, please. And the aim of GIRI is to improve construction productivity and quality by eliminating error. And I think that's a key point. It's not about checking that things are right, although that's clearly very important, but actually trying to ensure that we actually do things right first time. Happy to talk about our activities outside of today's forum because I don't want to take up too much time, but that's sort of the fundamentals of what GIRI is about. Next slide, please. So our aims and objectives. And you can see we talk about culture and a working environment. We talk about attitudes and harnessing leadership responsibility to reduce error. And again, a slight aside from today, but we do wonder what's going to happen as we get out of COVID-19's restrictions. And are people just going to be getting on with things, and are there going to be even more errors? I think unfortunately there's a bit of a view that might happen despite what we're trying to do. But I'm not reading through them all, but the very last one is improving skills across the sector and creating a positive approach to preempting error. And that's really why we've set up this workshop today, because it is about preempting error. Next slide, please. So our current membership is 53. We have some government advisory bodies. We've got clients, architects, structural and M&E engineers, tier 1 and tier 2 contractors, lawyers, insurers and insurance brokers. So quite a wide range of people. And actually it's particularly important, I think, that we have the insurance world involved with us, because I think they're very much part of what we do, and perhaps we don't understand each other as well as we might do. Next slide, please. So that just gives you a flavor of the people who are members. The companies are members, and they're members. These are the members as of about now. And so it's a very wide-ranging group, and probably one of the widest ranging groups in our industry. Next slide, please. So why today's webinar? Reducing error reduces insurance claims, which reduces premiums and hence costs. It's pretty simple, really. So premiums are always higher than the claims that are paid. So clearly, from a company point of view, an industry point of view, although they might get recovery, they're still paying even more, and our insurance colleagues will certainly tell us that. I also wonder whether insurance makes us complacent. Interesting enough, not on today's subject specifically, but post-Grenfell, some items and some issues are unlikely to be insurable. And then premiums are rising, and not all issues are covered by insurance. So we have something to learn. And because of the losses that we're all incurring, today's seminar is very pertinent. Next slide, please. So we need to help insurers to help us. So that's the purpose of today. And so I'm just looking forward to hearing what our colleagues have to say and the discussion thereafter. So I'd now like to welcome Robert and Matthew from Zurich, who's going to take us on from here. So Robert, thank you.
Well, thank you. Yep, so my name's Robert Innes. I'm a senior construction risk engineer for Zurich, and I'll be handing over to Matthew Porter shortly who's one of the executive adjusters dealing with construction claims. So if you could just go on to the next slide, please. Tom's been through most of this, so again, we don't need to say anything, but if you could just actually, one point that wasn't made, if you could just, on the participants list, if you could just click on to the right of your name and just rename yourself if your names come up not as your full name, just so we can have an idea of actually who's attended the webinar. That would be really appreciated. And again, this is just a note just to say, obviously this session's just for information purposes. We're just sharing some experiences. We're not here just to give you advice, we're just here to sort of help you. And obviously we reference losses, but obviously we're keeping these anonymous and we're using hypothetical examples where possible. So you could just move on to the next example. So next slide. Again, Tom's touched on this, but for me, knowledge sharing within organizations is usually pretty good. We're all good at it. But I think one thing we lack is actually sharing knowledge between organizations. So hopefully webinars such as this and knowledge sharing events, we can sort of overcome that and share best practice so we can basically all improve, because it benefits us all. It benefits clients, contractors, it benefits us as an insurance company. So that's what we're here to do. So hopefully this will be the first in a number of events of this type. So next slide, please, Helena. So I'll take you through just sort of an introduction, just to set the scene, like the scale of the problem, some examples of, where we've seen large losses, and then just touch upon how this is impacting you on your insurance, go through root causes, but then really focus on how can we get it right. That's what GIRI's all about, trying to avoid these errors and mistakes and how we can get this right first time. And then hopefully we'll have 25 minutes or so for Q&A at the end, where we just want to really encourage discussion, just understand what people are doing, what other people consider best practice, so we can all basically learn from one another. The next slide, please. This was on the flyer, so most people should be aware of this, but it just really highlights why we're focusing on this as our initial topic, because 31% of our claims are through escape of water events. So they're not the most with the highest value, but they actually, when you accumulate them all together, they actually total quite a large volume. So we paid out about 930 million in claims in 2018. And the cost per claim, as you can see, has gone up by 50%. So that's why we've chosen this as an initial topic, something that we really want to try and improve upon. So next slide, please. I'm just going to hand you over to Matt, who's just going to talk you through just some examples of losses that we've seen recently.
Yeah, thanks, Rob. Afternoon, everybody. Yeah, we've got 5 losses just to run through with you. There are some basic details on the slides about each of them. I'm not going to talk through every point, but we'll kick off with this, the first one. So we've got 8 escape of water claims totaling around about £8.5 million. One claim on its own caused a loss of £5 million. These losses were primarily caused by poorly crimped water pipes, which burst under pressure. And the larger escape of water event was due to leaking shower units in a multiple number of the apartments throughout the project. Now, we were trying to just tease out the costs to the contractor that weren't picked up by insurance here. And obviously the contractors had to pay for the deductibles. So there's 8 claims, it's £25,000 deductible per loss. Also, there was a claim, part of the claim submission was for idle time and liquidated damages, which are not covered under this particular policy of insurance, or really generally any other policy of insurance from a first party sort of property damage perspective. You will get some amendments to that, but in the main, it's not a recoverable cost to insurance. Next slide, please. Okay, so this is again quite a significant development, 500 million plus contract. Again, multiple escape of water events, totaling around about £3.5 million. This was at probably the worst time that it could have happened, just prior to practical completion. And we had a leak or series of leaks during testing. which then caused damage to other units below the flat where the leak occurred. A root cause of this was a faulty plastic welded joint, so probably a material issue. Quite a significant impact on the contractor, about nearly £600,000 of unrecoverable costs, including deductibles and works not covered by insurance. The last point is quite interesting in terms of the initial deductible for escape of water was £5,000. During the course of the number of losses that occurred over the project, it was increased to £50,000 and then ultimately to £500,000. Basically, the contractor at that point, or any of the insured parties, would have been having to pay a considerable amount out of their own pockets in the event of a further escape of water loss. Next slide, please. Okay, this is a slightly lower value loss, but the sort of fundamentals are the same. It's basically occasioned multiple losses due to a failure of either workmanship or specification of a particular material to be used between a stainless steel slot drain and waterproofing membrane. Costs to the contractor were around about £170,000 in deductibles, multiple deductibles, and costs just generally not covered under the insurance. And there's also an element for idle time and delay, which again, not typically picked up under a CAR insurance cover. Next slide, please. This is another fairly significant loss of £3 million. There had been a previous escape of water event with a crimp joint. There was some testing done. It appears, unfortunately, the pipe that failed was not part of the batch that were tested. Again, significant, quite a prolonged escape of water. Although it was caught on CCTV, the security team failed to notice the issue, and I think the water continued to flow for a period of time. Again, you know, gravity allows water to move downwards, which it did in this occasion, damaging fixtures and fittings in rooms below the source of the leak. This was, again, a workmanship issue. Some may say also supervision issue. Pipe that failed wasn't inserted to the correct depth for crimping. You can see there's quite a significant difference between the amount that it was inserted and the amount it should have been. And there's a possibility also that the crimping equipment may have been defective. The cost of the contractor, again, through deductibles, unrecoverable costs, idle time, £410,000. Next slide, please. Okay, this was a wide-scale residential contract, significant contract value. We dealt with a claim for leaking radiators and heating pipe work occasioned by corrosion. Ultimately, this claim was settled for £14 million. The overall cost of the contractor was £32 million, so there's a bit of a delta there. Point to make. Root causes on this were failure of rust inhibitor and general treatment of the closed water systems, the inappropriate use of polypropylene pipe, which caused situation of over-oxygenation, allowing the corrosion to spread and multiply. The further issue here was that the radiators used were wet tested and not cleaned or emptied properly, so they sat for a period of time before proper installation with water inside them, allowing the corrosion process to kick off. Couple of points to make really at the end of these examples. As Tom stated earlier, the insurance won't cover everything. There's always going to be unrecoverable costs from your insurance covers. You know, your costs in terms of reinstatement of damaged property always have to be reasonable. There's exclusions to deal with. There's issues over unit rates and materials and labour being too high. There's deductibles, as we talked about. And there's always idle time and delay or liquidated damages, which are pretty exclusively not covered by these policies. And the last thing I'd like to say really is, given that there's relatively low margins on a lot of these contracts, and you've got the inevitability of unrecoverable costs, avoiding loss at the outset by getting it right really must be the way forward on this. All right, thank you very much. I'm going to hand back to Rob, who's going to continue on.
Yeah, thanks, Matt. Again, Matt's obviously pointed out some of the direct costs, but there's also sort of indirect costs that we're looking at. Obviously, there's the impact on insurance and premiums and deductibles. And obviously, there are many factors that go into, coming up with your premium and deductibles based on, project type and who's doing it, etc. But, escape of water does have an impact. And these are just some of the things that we're seeing in the market. There is more prescriptive coverage with regard to water damage. There are certain projects that are requiring certain measures that need to be in place in order to be sort of part of the insurance policy. And even in some cases, you're finding insurance carriers sort of declining wanting to participate in projects, which means that you've got a reduction in potential carriers, which will then inevitably then reduces your competition. So therefore you've got less insurers wanting to participate, which will then have an impact on your premiums. And what you're generally seeing are premiums going across the board. And again, this is as a result effectively from, increases in claims that we're seeing. And again, another point just to raise with premiums again is just obviously where projects are being delayed, potentially you are looking to have to extend your policy, and therefore effectively you're going to be paying more premium as a result. And as Matt pointed out previously, obviously we showed an example where a premium, a deductible 5,000 to 500,000. Generally across the insurance market, we're seeing deductibles. They used to be in the order of 5,000 to 10,000, but now we're seeing them in the order of 50 to 75,000 pounds, because this is how the insurance market is responding to these type of events. So these are your indirect costs that you're all facing, whether you have claims or not. This is a problem that you're all facing, because collectively that's how we have to deal with this. Please. Okay, so Matt touched upon some of the root causes, and predominantly joints are your biggest cause, whether they're not inserted to the correct depth, not crimped correctly, and it makes it really difficult to actually ascertain whether they've been installed correctly or not. You can't tell if it's gone in 13 mil or 30 mil. It's very difficult to put it up. Again, it's workmanship that's sort of leading to all of these. So it's either lack of supervision, mistakes are being missed, either we've got a lack of competency within the workforce, a lack of training, or even it comes down to inadequate testing and commissioning regimes. I've seen examples just going through claims recently where the test, it's gone through inspection and testing, and it's come out fine, but actually the joint had failed because it was just actually being held in position by the actual fixings of the pipes, not necessarily the joint. And even though it passed the inspection testing regime, it subsequently failed. So again, just because it's gone through that regime doesn't mean that everything's A-okay. So again, that's an area that we really need to focus on. And you'll notice most of the examples that Matt mentioned involved joint failure. And it only takes one joint to fail. That's the sad fact is you could have 99% which are perfect, but one joint fails and then you could have a massive loss. The other sort of thing we're seeing again is water, due to gravity, it percolates down the building. So you might have a water leak on one floor, but it will then certainly cause damage to floors below. And that's predominantly through openings in floors such as risers. And again, what we're seeing is water leaks are being discovered many hours actually after they've started. And it always seems to happen as they're nearing practical completion. So again, several of the examples that Matt referenced, they were going through snagging. They were literally so close to handing over, and then you've got an escape of water event. And we're seeing projects being delayed up to a year as a result of this. And then just another which doesn't help in the extent of damage, is that just having an action plan of what to do in such an event. So Matt mentioned that obviously one of the escape of water events was noticed on CCTV, but then it was several hours before that actually was rectified, which again just exacerbates the extent of damage that we're seeing. And again, with reference to materials, sometimes we're seeing poor quality materials that are being used. They're either not approved or they're deviating from the specification. You know, and we're thinking that's along the lines of potential value engineering, trying to cut corners, cut costs, or even just due to program and cost pressures. So they're generally sort of the root causes. There's many more, but they're the typical ones that we're seeing that either cause the failure or exacerbate the extent of damage. Next slide, please. So the main aim is just how can we get this right? So in my opinion is I would treat this in the same way you treat a fire. So my first protocol would always be go to best practice guidance. So there is best practice guidance out there. And there's a CIREG document that we offer in reference, which is free to download. It's accessible. So I would encourage people to have a look at that and digest that. Zurich has got best practice guidance out there, and there's a fluid book, which you can easily Google, which again, I'd recommend having a look at. But the main one is I would start with a water management plan. And often we go to site and, you know, sites don't have this. And again, it's just there just to outline who's managing the risk, you know, details of an emergency action plan, what your quality control standards are and procedures are. And again, just dealing with competency and what mitigation measures that you've got in place, both the permanent and temporary water supplies. So this is in addition to your inspection testing plans. This is what we'd expect contractors to be able to produce. And there's guidance in this, the CIREG document above, which outlines how to put one together. Next slide, please. Again, often we you know, what we look for is an emergency action plan, what you're meant to do in this event. I think often there's an assumption that, you know, the M&E contractor will be on site and they'll be the person to deal with the problem. But often what you'll find is they're not on site, or they may have either left the project completely, or again, it's out of hours. So simple procedures just to, what do you do? Who do you contact? Where are the isolation valves? Where they're located on drawings, and have clear signage. You'd have the same as an emergency action plan for a fire event. Again, it's something simple we could probably do for what do we do in an escape of water event. And then I just move on to water work permits. Again, this is just aligning it to what we do for fire. Again, Zurich have got an escape of water permit. All water work should really have a permit that needs to be taken out, similar to what you do with a hot works permit. Again, it just provides you a bit of control as to what works are going on, who's got ownership for them, and have they been closed out. And it's something I often ask for when I go to visit projects is, do they use a water watch? Again, similar to a fire watch, something where you're not doing any testing commissioning in the last hour. And you actually just do a visual inspection of the pipe or pipe work once you've finished it, just to ensure that there isn't any leaking pipes. And you do this up to an hour after after you've stopped. And again, you just do a final check at the end of the day. It just gives you an extra level of comfort that there isn't a leaking pipe out there that will happen and will burst or is leaking overnight. This just gives you an opportunity to identify it and rectify it if need be. Because sometimes these leaks are very subtle, and then they grow. And again, just touching on improving quality control, and this is mainly focused at joints. Again, putting together test joints, visually inspecting them and testing them, and just making sure that the standard of joint that's going into the project is of a high standard. And we would also recommend, it's intensive in terms of work, but just where possible, to label or mark your joints or record them using applications such as Field View. You know, most people have got smart devices, iPhones, iPads, where you can actually just register who's actually installed that joint. And that really helps if you develop a workmanship issue, to being able to identify what joints have been affected and could be affected. And it just reduces the amount of rectification work that you've got involved. So again, on a previous project that Matt referred to, you know, they tested all the large diameter pipes, but they didn't test the small diameter. Now, if that was a workmanship issue with a particular worker, you know, you could easily identify all their joints and inspect them all, rather than just assuming it's all the large diameter pipes, etc. And again, we would recommend just obviously following the manufacturer's recommendations with regard to pressure testing. Next slide, please. And again, just checking competency. Again, we do this during the induction process, but again, we recommend just periodically reviewing this during the works. Again, just checking that the people that are carrying out the works are actually qualified to do so, because often you do find that sometimes people intermingle their professions and dabble in a bit of you know, heating and plumbing and stuff like that when they shouldn't do so. It's just making sure that the right people are doing the right works. And you know, we've got some, you know, guidance as to what sort of competency we'd be looking at. That's what we reference in this IREG document. Temporary water supplies is another area that we focus on, because not necessarily because we get an abundance of leaks or claims from those, but it's just something that's often neglected because there's a lot of focus on the permanent supply. So again, it's just checking, making sure that, you know, where you can install leak detection or even isolate your temporary supply, either over the weekends or on a daily basis. And with regard to leak detection, this goes for permanent supplies as well as temporary, where possible. It's just making sure they actually work, not necessarily assuming that they work. Actually test them on a frequent basis, because you don't really want to find out that your leak detection is not working at the time that you actually need it. And again, just do a regular inspection of your temporary water supplies. Again, we wouldn't want that failure in that when you put some hard work into getting your permanent supply correct. And then lastly, just focusing on minimizing the spread. Again, often we see it occurs on one floor and spreads quite quickly and easily down to lower floors. So we want to try and reduce that where possible. So again, eliminating openings in floor structure above electrical rooms, just obviously so we don't damage that equipment. Something simple, installing upstands around all your floor openings. That's something I used to do when I was a design engineer. Again, it just buys you time as much as anything. If you've got a significant water leak, it might encroach over the top of it, but it will still buy you time. And again, locating water tanks where possible on the lowest floor, and just installing any permanent plant and equipment on raised concrete plinths. I mean, these are just some of the ideas. And again, you know, it's not, we know it all and this is what you should be doing. I mean, this is what we recommend to do as much as you can, but we're also just looking for ideas and influence from yourselves. What are you finding practical and what you would recommend? So this is why we want to do this as a knowledge sharing exercise, so we can try and learn from each other. So next slide, please. So I'm just going to hand you over to Paul Lowe, who's just going to talk you through his experience from a legal point of view.
I want to give a brief introduction to what we see from a legal perspective. The main issues are the ones you'll see on this slide. We see ourselves as being part of the solution rather than a problem, but unfortunately too many of these escape water cases come across our desks. And what we're asked to do, very breaking the terms of the policies, to pursuing claims against guilty parties. And of course, there's a vast array of professionals and supply chain organisations involved in escape water claims, and they unfortunately are very expensive. I mean, there's nothing like personal experience to drive these messages home. I can recall receiving a telephone call from my wife one afternoon while I was at work, asking me why there was a torrent of water pouring through our kitchen ceiling, which had been caused by a burst pipe in a bathroom. So many of us will have a first-hand experience like that. Next slide, please, Hannah. There's an increasing trend in connection with these claims. There's a lot of research has been carried out. You've heard Tom and Matt have had to say. Part of this, I think, is to do with the nature of materials and workmanship which have been used in flouts. Plastic components and concealed pipework unfortunately lend to the challenge and the difficulty of discovering resource leaks in our experience. There's obviously an increasing dynamic in the way we use our buildings, particularly within the housing market, where multiple occupancy leads to greater costs and greater losses for the insurers. And at the same time, the cost to make a good those repairs increases at the same time. So there's a dynamic here which we as lawyers see, and is one which unfortunately due to be a growing one. Next slide, Helena. On that note, I think I will drop out before before this gets even worse, and let Simon do the talking.
Well, hello again, everyone. I think what we just witnessed was testament to the fact that even with the best laid plans, circumstances can conspire against you. But anyway, hopefully you can all hear me. Thanks, Paul, for your comments. So as we heard earlier, escape of water can result from many different causes, such as poor installation and workmanship, production and manufacturing defects, poor component design, physical or mechanical damage, sometimes even deliberately caused, weather-dependent temperature fluctuations, such as thawing or frozen pipework, gradual deterioration over time, including, of course, the effects of corrosion, and pressure fluctuations and what's sometimes known as a water hammer. In our experience, and this I think was borne out by what Rob and Matt mentioned earlier, the most common cause of water escapes is poor workmanship. This trend can be seen across a whole range of different types of pipe work fittings, including push fit, compression, soldered connections, with the failure of push fit fittings and compression fittings perhaps being the most frequent. Now, these failures can be the result of, or partial result of, the use of incompatible components of incorrect sizing or produced by different manufacturers, the failure to install pipe inserts or to ensure the pipe is fully housed within the fitting body of the connection, or of course of cross-threading or over-tightening of components. Now, manufacture and design issues also play a key role and can be experienced in many forms, including the provision of components produced with substandard or improperly graded materials, the provision of incompatible or oversized components within a product set, or poor product production where machine failures or human error can cause small variances in thread sizes, wall thickness, and the like, resulting in a product that fails before its stated specification limits. Now, whilst the spotlight of liability will inevitably shine brightest on the contractor who actually executed the work, others in the contractual chain may inevitably also end up carrying the can. Liability may also fall on a manufacturer should the quality of installation instructions provided with the fitting or available online be insufficient for the application required. Unpicking what went wrong and who's to blame, both factually and legally, is often a minefield, but frankly, whilst legal liability may be contested on the basis of contractual indemnities or exclusions, and the search for the party responsible for the loss can go on, this is a little consolation for an innocent contractor caught up in a dispute following a loss, not least because of the damage it can do to relationships and the business brand and the time cost and distraction and disruption that it entails. It's therefore, of course, in the best interest of everyone involved in a project to avoid or minimize risk and loss wherever possible. The challenge, therefore, is to avert or reduce the chances of making mistakes, preempt through forward planning the consequences of such mistakes, and putting into action appropriate steps to mitigate and respond to the loss once it occurs. I'd like to illustrate this challenge with reference to a case which I'm currently working on and to draw some practical tips from it. Next slide, please, Helena. We're instructed on behalf of an office fit-out contractor. The contract was a JCT standard form of building contract, and it involved a large modern office block in London. We subcontracted the design and installation of the sprinkler system to a subcontractor. Now, project went pretty smoothly. 3 years down the line, 3 years after practical completion, late one evening, no one's in the vicinity, the sprinkler spontaneously fails on one of the top floors. It always seems to be near the top of the floor, top of the building, doesn't it? But it caused significant water damage to the building and rendered large parts of it unusable for many months and caused considerable BI losses. As the contractor responsible for the fit out, our client was sued on the basis of breach of contract in relation to issues regarding the design of the sprinkler system. This was because it transpired that the sprinkler failure was probably caused by its continual impact by a heavy lobby door. This had happened because the door close mechanism had failed relatively early on in its life, allowing the door to open beyond its designed and intended 90-degree opening range. Essentially, the sprinkler head became a doorstop. On liability, the question hinged, no pun intended, upon whether the design was appropriate, specifically whether a protruding sprinkler head should ever have been situated within the arc of the door, even though it could only really pose an issue upon failure of the door close mechanism. Ultimately, the claim was settled and we're in the process of seeking a contribution from the subbie responsible for the design and installation. There were various contractual reasons why it was difficult for us to bring them in earlier. But one of the key features of this case, I think, and the reason why I mention it is because the catalogue of missed opportunities to prevent, minimize, and mitigate the loss throughout the life of the matter. First, the design itself was clearly not sufficiently robust. There was no good safety or design reason why the sprinkler in question needed to be fitted within the overreach arc of the door. And it was probably not a good defense for us to say that the failure of the hinge was not reasonably foreseeable. Further, insufficient consideration had been given to the height of the door relative to the protrusion of the sprinkler. Could the clearance between the door and the head have been increased? Could a less obtrusive head have been used? So, practical tip here, in terms of the initial design phase, you need to make sure that it's thoroughly reviewed prior to implementation, and a thorough review could have flushed out the issue, possibly at minimal additional cost, and thereby avert a much more significant loss later on. Secondly, just before practical completion, the protective boards previously concealing the precise location and height of the door were removed. A simple visual check could have identified the risk of impact of the door with the sprinkler head upon overreach. So from a practical perspective, it's always worth considering whether there are any obvious issues, potential ways pipes or sprinkler heads, for example, could be inadvertently damaged through the normal operation of the premises. It's also often easy to see issues in real life when you're there on site instead of just looking at them on paper and relying on plans and designs. Thirdly, we know from the maintenance records that a year and a half after practical completion, door stops were fitted to the incident door to prevent it from opening wider than the 90 degrees. But for reasons that remain unclear, they were removed a year and a half after they were fitted, but the door itself was not fixed in the meantime. So whilst likely to have been a mistake on the part of the maintenance team, it was probably not the fault of the claimant tenant, and the claim could not be defended again on this basis. But also regular maintenance of the sprinkler system failed to pick up on the issue. So again, practical tip here, maintenance issues should be proactively managed and addressed. Temporary repairs need to be remedied and not just left as temporary fixes. And obviously, whilst you can't legislate for others not doing their jobs properly, you can maximize the chances of them doing so by issuing clear guidance and instructions throughout the project, as well as on handover. Fourthly, there was no emergency response plan in place by the landlord or the tenant. The security team on watch that night were slow to respond. They had no idea what to do. I think the CCTV footage showed them coming up with toilet paper to try and absorb some of the water. They didn't know where the local isolation valves were, and as a result, it took 45 minutes to an hour for them to actually turn the sprinkler off. I think they had to get the fire brigade in, and that would have caused a huge additional damage. So ensuring appropriate plans are in place to respond to an escape of water event, and that all personnel are briefed, is absolutely essential. Isolation valves should be clearly identified, as Rob said. during the course of projects, there should be a water management plan, which is absolutely essential. Fifthly and lastly, the door was disposed of before forensic investigations were properly advanced. Witness statements were not taken promptly. Relevant documents were not preserved. Indeed, we often experience a whole range of issues with forensic and factual investigations, including delays in attendance at site, evidence destroyed or disposed of prior to forensic investigations, manufacturers or installers permitted to recover or examine evidence before independent forensic are appointed, and scene repair and clean up prior to forensic examination. So not only does this hinder your chances of establishing what went wrong and learning lessons from that, but it can greatly restrict the prospects of pursuing a recovery against a responsible third party. And in the worst case, it could prejudice your insurance cover. So in the event of a loss, know what the process is, know what the procedures are, know who to call, and act accordingly. And then finally, on the subject of insurance, as we've seen and heard today, insurers have a wealth of experience and are a source of helpful information and assistance. Many insureds forget that insurers are there to support and assist, not just in the aftermath of the claim, but before the event. We saw a good example of this earlier in the form of the Zurich Escape of Water Permit and the Zurich Fluid Book. So you shouldn't hesitate to reach out to your friendly insurer, either directly or via your broker, where you have a specific question regarding best practice or risk management. And the same goes for us lawyers too. So please don't hesitate to get in touch with any questions. Back to you, Tom.
Thanks, Simon. That was really interesting, all of what you all had to say. And I hope that despite the sort of slight glitches with the internet, that you managed to hear what everybody had to say. So to try and get the questions and keep it orderly, because it's difficult with the large number of people we've got, I'm asking if you could, if you've got some questions and comments, and some people already asked them, so I'll come back to them in a moment. And then I'll ask you to speak, and then you can perhaps unmute as necessary. And some of the questions, I'm just going to make a slightly trite point to start with, or a couple of trite points. We've talked a lot about effectively not following specifications and things like that. Well, maybe our specification for today wasn't particularly clear, but one of the things we asked people to do was to name themselves on their device so that we could recognize who they were. Well, there are two people who I don't know who they are, and therefore they're not coming, because we're also quite worried about Zoom and some of the things that happen with it. So we're ourselves, even though we are participant in this, are not always as good as we could be in reading the instructions. And I think that's a pretty important point for our industry as a whole. Second comment I just make, I know there is a huge dilemma about pipe joints, but there are certain companies I know that will not allow crimp joints, full stop. And it's just, again, it doesn't, I mean, it's a few years since I was actively involved in the industry. We had terrible troubles with crimp joints before, and it seems that nothing's changed, and yet we're still doing the same thing. Isn't that what Einstein said was one of the signs of madness? I don't know. So I just whiz through, sorry, forgive me for that, the questions that have been raised. So if you've got questions, please, if you could type them in, and we'll see where we go, basically. There's Andy Desmond talked about leak detection, and Yaron Dyson from Wint Water talked about that their company provides leak detection. I will say, because I did a little bit of research before today, that if you go on their website, it explains quite clearly what they do. I don't know, Yaron, whether you want to say anything on that?
Yes, thank you. So I don't want this to be an advertisement, of course, but thanks for the opportunity. We do provide solutions that use advanced IoT devices and artificial intelligence to prevent leaks in construction sites. We work with some of the world's largest, and we actually have customers who have deployed us at over 40 projects to basically end all of their water damage events. So, we'll be happy to discuss that. I will also say that some of the information provided initially about the hidden costs or the uncovered costs, unrelated to our products, we've done a lot of work to develop models that try to analyze the actual cost to a main contractor for or as a result of water damage. These numbers get quite scary, and you can see significant impact on the margins. From our experience, the solutions really do work, and they really do prevent the damage. And these things can be taken away with a pretty simple set of installations of water devices on maybe 10 or 15 pipe points in a construction site, not a big endeavor. And the issue practically goes away.
Just answering Andy's question, it's sort of like difficult in the sense that because good risk management, in theory, eliminates claims. So it's you only get to see these things when things go wrong. But I would just always encourage the installation of them, because I don't think they're very expensive. And even if it's just, I mean, it has to be compatible with your permanent water supplies, but even just installing it on your temporary water supply can only be beneficial, in my opinion. And again, I think a lot of the solutions that we generally recommend, we always try and make them cost effective, so it's not costing the world to do this. So it's difficult. I don't have any examples offhand. If I do, I'll let you know. But because they're there to effectively to help reduce the water flow, if in the case in it, and they only have to be operational during, in particular, out of hours, because obviously you're doing your testing commissioning and you wouldn't want to interfere with that. But even if you just have them working for during out of hours periods, then that's beneficial. And even if you have permanent water leak detection, even just if that could be made operational earlier in the project, then again that can only benefit us.
Yeah, it's Andy here. I just wanted to say I understand that how they work, but so my history is I used to be insurance manager for a major UK D&B contractor. I just wondered whether the kind of leak detection people and the insurance people could get together and demonstrate, look, this is our leak detection went off at 2 a.m. on a Friday night. And it was a 150 mil water main that had burst, and the leak detection shut down the water supply, and the cost of damage was £2,000 to rectify it. We as insurers have got an example of another claim where a 150 mil water main went off or burst at in the middle of the night, and the resulting claim flowing from that was £600,000. That kind of information would be really powerful in terms of kind of getting traction for the leak detection side of things.
If I may add to that. Oh, sorry.
Sorry, I was going to say, in principle, that sounds really good. And if we come across that, then I think we could share it. But then I'd also say is where these devices are being used, because sometimes they may prevent a claim from occurring, because we'll only see it when a claim occurs. But if you have examples, so this is where contractors can help as well, where contractors have examples of where it's well, and they can then relay that information to other contractors or to the insurance industry as well, then that would be beneficial. But I agree.
And if I may, this is Yaron again. We have examples, right from probably most of the people on the call's backyard at Howard the Walden of cases where we stopped water leaks right when they started in the middle of the night. The worst case scenario you can imagine, and basically prevented the leak. So we have quite a few of those, multiple.
Sorry, I realised I was talking to myself. Apologies for that. That's really useful, but the fact is that water leak detection is really useful, and I get that. But equally, it isn't actually the root cause as to why the water's leaking in the first place. I wonder if anybody'd like to comment on the fact that why do we still use crimp joints when we know that they fail with monotonous regularity? Has anybody got a view on that?
Speed.
Who's that?
Andy Desmond.
Okay, Andy, would you like to comment on that? Why do we use them if they're so bad?
Fundamentally, so there's two issues here. One is speed and cost, and the second, I think, is kind of the workmanship issue. So I have seen some. Is the design issue, sorry. Now, I have seen some kind of crimp push fit joints that is almost impossible to install incorrectly. So it's obviously a new technology, crimp fit and push fit. If you go back 15, 20 years, pretty much all of the water in buildings was done via copper pipe work, and they were generally soldered joints. And if you solder a joint and it's done correctly and it passes an air test, then it's pretty well stuck together. When you start getting new technology, and we have crimp fitting and push fitting, you can see scenarios where they can pass an air test, so it's connected but not fully seated within the joint itself. An example was shown in the presentation earlier, where it was only seated 13 mil as opposed to 50 mil or whatever the technical specs were. And that will pass an air test, and it will work for a little while, and then it pops. I think it really comes back to a manufacturing stroke design issue where we need to get onto kind of the second and third generation of these crimp fit and push fits, which have fail safes built into them that prevents you from installing them incorrectly.
Yeah. Okay. Thanks for that, Andy. Will Pitt, I think you had your hand up. No? Okay.
Tom, hi. Yeah, I am here.
All right.
Yeah, just a brief point. It's Will Pitt, NG Bailey Division Engineering Manager. We use press fit pipework as a standard across the business. Press fit, often referred to as crimped. I think if the workmanship is properly managed, and we've got very rigorous procedures in place to do that, then it's absolutely fine. The reason the industry uses that, I think we've moved away from hot works on site, so soldering, there was issues with quality, there's issues with getting skills available. So press fit is an industry standard, and if it is properly managed, and it's all about the quality of the workmanship, and we've got processes in place to do that, and there's nothing wrong with it. And we've got things I'm more than happy to share with you guys on how we manage that. It's all about managing the workmanship.
Okay. Will, that'd be really good, and maybe perhaps you could drop me a line afterwards and we can take it from there. I'm just going to make the comment that some of you will have heard me say many, many times. So in all of our cars, we have a pipe that connects a petrol tank or diesel tank to an engine. So it's carrying highly flammable liquid, and it's connected by a production worker in a factory. And I'm sure it is absolutely designed so the production worker cannot fit it in correctly. And for the life of me, I mean, maybe the second or third generation fittings that you're talking about, Will, are getting closer to there, but I don't understand why we can't get to the same place. So yes, supervision is great, but you still get the rogue, whatever it is. If it actually can only be done correctly, as poka-yoke, as the Japanese talk about, that's really where we want to go. Anyway, I think we're going to have to draw this to a close because I think we're coming up to 3 o'clock. So can I have the next slide, please? So I hope you found this useful. I'm sorry if one or two of the things didn't quite go as we planned, but that's just, I suppose, one of those things. And the internet, I think the internet is under stress at the moment with all that we're all doing. We'd be really interested if you to suggest any other topics that you would like to discuss. Obviously, some of the topics and have been listed down here is hot work fires, cladding remediation, regulatory and legislative changes, and then restarting construction projects after COVID-19. And as I've already said, I think there is some quite potential serious risks in that. The forum that we ran this time last week, most people reckoned that our cost of error would go up by, or error correction would probably go up by 20%. So instead of being 21%, be about 26%. So pretty scary numbers. So anyway, thank you for, if I can have the next slide, please. Thank you for that. We will have emailed to you a survey, which we would really like you to send back to us. Then we will try and improve it and make it better next time. So as I said, and we've actually got another members meeting, slightly later next Thursday, and which we're going to be talking about managing and motivating staff during COVID-19, because I think some quite serious issues with that. Difference between those who've been furloughed and those who've not been furloughed, for instance. And we've already had some comments in the past about that. So with that, I'd like to thank you very much indeed. And I hope you keep safe in these difficult times. And I hope you find it interesting. Thanks very much indeed. Goodbye.
Thank you very much.